Hi viewers, this is Manikanta. In the last video, we have gone through introduction of G codes and M codes, and in the previous video, I also covered a list of some important M codes. And in this video, we will see G codes. As I said in introduction, G codes are universal codes. It means wherever you go, the G codes will never change and it will be same at anywhere. The first code is G0, G00. It's a rapid traverse code. It means the movement of the turret will be rapid, and it says that the mission will consist of some fixed feed. That means somehow it's 10,000 mm per revolution. In G00, the turret will move in the fixed speed of the mission. And G01, it's a code of linear movement with feed. It says that in G0, the turret moves with rapid speed, but in G01, the amount of feed we mentioned will take into consideration and the turret move according to it. And we use G001 for linear movements such as in X, Y, Z directions. Sorry, not Y. In a linear direction only, we use G01. By using this, we can produce chamfers, tappers, etc. For chamfers, we're using G01. For arcs or fillets, then we use G02 and G03. G02 is clockwise circular interpolation and G03 is counterclockwise circular progression. It means the way the tool travels depends upon this G02 and G03. For example, when the tool travels from this direction to here and then this direction, it means it's a clockwise direction. Then we use G02. And if the tool needs to travel in this way to here, it means the tool traveling in anti-clockwise direction. Then we use G03. Later, here the format will be some G02, example G02 X some value and Z some value. Then we should mention the radius of the fillet, something 2.0, and also we mention here the amount of feed the tool should move. In the same way, G03. Then later G04. G04 means dwell time. It means when for example, a step turning is going on and the one tool cutting has been completed. The latter, we move the turret aside and we stop there for a tool change. Then, or chip removal purpose, we stop for a few seconds and later the cutting has been done. Same. For those conditions, we use G04. The format will be G04 X 1.0. Here D04 is the command of dwell time. Here X we can take as a time variable, and 1.0 is the time in seconds. Later G20 and G21. These codes use it to say that how the program has been written. The program may be written in inches or mm. It means the coordinates taken in the program may be inches or mm. This can be differentiated by using G20 and G21. Later, G28. It's a home position code. It means return to home position. Every mission has some fixed home position, and it means after the operation, the turret moves to home position. It's a turret. And spindle. When we use this code, wherever the turret will be, the turret goes to its home position. It means when we use the code can be used in G28, U0.0 and W0.0. Whenever you mention this code in the program, the turret will move to home position with a rapid speed. Letter G30. It is also the same written to home position, but it is second, third, etc. The mission has some initial home position. Beyond that, we keep extra home positions for reducing the missioning time. It means when we're missioning a large workpiece, it means in the meters, in long rod, when we're missioning a long length missioning rods, when the tool, after completion of one tool, again when it goes to home position and changing tool, it takes a long time. To reduce this time, we can fix a second home position or third home positions, so that we can save the time. We can reduce machining time. Later, G40, G41, G42. These are tool compensation codes. It says that how the tool is, the tool position. It means if the tool cuts in this direction, we use G41, and when the tool goes in this direction, we use G42. This is tool compensation. We use tool compensation here. Circular interpolations. When we are producing arc, we mention the tool direction. It means how the halt is a left hand or right hand. It can be differentiated by this G40, 41, 42. G40 is a tool compensation of G41, tool compensation left, and G42, tool compensation right. After completion of this G41, G42, we should mention G40 after the program compulsory. Next, G43, G44. These codes describes about tool length, whether the tool length is in positive or negative. Mainly we use in these codes can be used in milling, because milling we mention the tool heights. The tool height we mention either in positive or negative. It can be known by using G43 and G44. Now G53. G53 is mission coordinates. By using these mission coordinates, G53, we fix the mission datum. We fix mission datum points. Later, G54 to 59 are work coordinates. It means we fix work datum. That means the job which we do. Consider a spindle, a job has been fixed. In work coordinate G54, suppose we take G54 Z. Here we fix when the tool moves to workpiece, and we measure here as a Z0.0. Then we can get some coordinate value like -345, 65 something. It means here we fix it is the datum of the workpiece. The program can be written from here by considering as the workpiece datum. The program can be written. Next, G71 to G76 and G86 are Cannet cycle codes. In separate video, I can explain about Cannet cycles. Now next, G90 and G90 is a absolute programming code, and G91 is a incremental programming code. It means it decides how the program has been written. The program has been written in absolute. It means the tool must travel A to B, B to C, C to D. Here, in absolute coordinate system, A is the initial point, and from the A, total length can be calculated. It means when the tool needs to travel A to B, the length has been taken as 10 mm, and next the tool needs to travel B to C. The length has been calculated from initial point A. It means total length is 25. If the tool needs to move from B to C, the length should be given as 25, and when it needs to move C to D, then also the initial point will be A, and the total length the distance can be calculated from the A only. It means 10 plus 15 and 20 is 45. When we mention 45, then the tool travel from C to D. But in incremental coordinate system, when the tool moves from A to B, then the tool initial position become here 0, and when the tool needs to travel from B to C, the distance to be moved can be calculated from the B. It means when the tool needs to move from B to C, the length from B to C has been given. Then the tool moves from B to C. Now we see how this absolute and incremental system works in lathe and milling. In lathe, in program we mention G01. When we mention X and Y, the programming gone in an absolute coordinate system, and when we mention U and W, the program will go in incremental coordinate system in lathes. In milling, here we mention for absolute we mention G90 and G91 for incremental. There is no need of mentioning G90 and G91 in lathes, but in milling we should compulsory mention G90 and G91. Next, G96. G96 is a surface spindle speed, and G97 is constant spindle speed. It means it says how the spindle should be rotated. As in the name, constant spindle speed. It means the spindle speed is constant throughout the cycle. When we mention at the start, when we mention the speed throughout the operation, the speed will be same. And in G96, the speed can be vary according to the diameter. It means here we mention tool speed limits, minimum and maximum. Here G50 is the maximum RPM preset. It means at the to how long the spindle speed should be is mentioned here. Thank you guys. I hope all you understand these G codes. For a minimum basic programming, these G codes are enough for writing a basic program like some step turnings, facings, etc. Thank you guys. In the next video, we will meet. Thank you. Please subscribe Manoj Gupta. Thank you.